Hello everyone, this is the TI-84 guy. I'm back. I have a video that I like to do, and it involves a few changes that I made to the Alinear program. I made some changes to the Alinear program earlier this summer, but I decided to make one more change. I think this is going to be it, but this is an important change, and I want to go over it. Essentially what I've done because I've given students the ability to solve a system of equations if there's 0 solutions, 1 solution, or infinite solutions. What I found in working with some of my students have struggled trying to solve problems that have no solutions or infinite solutions. So I decided to go ahead and add that ability to the Alinear program. So that's what this video is going to be about. If you have not seen my original Alinear video, I will include a link for it up here, and I would recommend that you go watch that first and then come back to watch this. If you already have the Alinear program, or if you are looking for something to help you solve systems of equations, this should be your program to watch. All right, so let me go ahead and jump right in here. Now, before I go over the changes to the program, I want to do a quick review. If you're dealing with a system of linear equations, there's 3 options. If the lines have different slopes, it's going to have 1 intersection. And you can see that in the middle of my screen here. Now, if you have 2 lines that are parallel, like the 2 black lines, those 2 parallel lines will not have any intersections, and therefore they will have no solutions. There are no solutions to that system, right? Now, the last situation, and I'm going to do my best to draw this, is if you have a line that's essentially, the same as this, then they will have an infinite number of solutions. Now, my drawing here was not the best, but I hope you get the idea. So let's go. We're going to start with a question that we could already do. And as I said before, if you are not familiar with the Alinear video, you should go watch that first. So first thing it says here is we have a linear system of equations. And because these 2 lines, which are in standard form, have different slopes, we know that it's going to have 1 solution. So the program, Alinear, will easily find the solution. So let's go and do that real quick. So if we go over to my calculator, and let me clear all of this stuff because I want this to be nice and clean. And let's clear this as well. All right, so what you would do is you would go to the program. It's going to be Alinear. I have a Z at the end because I didn't want to change my original program just yet until I had a chance to demo this, but it will be called Alinear. Now, first thing, press enter again, and it's going to give you all these options. This is where you need to go and watch my other video to see how these other options work. This video, we're only going to be dealing with option 5, system of equations. So you would press 5. Now, here's one of the changes. First menu you're going to see is it's going to say which solutions, how many solutions are you trying to find? 1 solution, no solution, or infinite solutions. In this case, we want 1 solution because we have 2 lines that are not parallel. So now what we have here is the equations were in standard form. The coefficient for the A term was 2. The coefficient for the B term was a -3. The constant was a -14. Just enter those, press enter. And now we're going to use the standard again for the second line, and the coefficient for the A term was 3. The coefficient for the B term is a -2, and the coefficient for the constant would be a -6. Press enter, and bam, that's our coordinates. Now, we weren't looking for x and y. We were actually looking for the difference between x and y. So 2 minus 6 would be a -4. If we go back over to our test, you would see that the choice would be C. All right, so that's kind of what the program could already do. Now, here is the change. All right, let's get my iPad oriented. All right, so here we have a system of equations here, but it says there's a constant K, and we have X and Y variables. It says for what value of K will the system have no solutions, right? So we want to find what do we need to put in for K so that this system will have no solution. Basically, what do we need to put in K so that these two lines are parallel? All right, so let's go. We would go back to the calculator. We are going to press enter, and we're going to press 5. We want no solution, so that's option 2. Now, the equations were in standard form, so we would choose 2. Now, the coefficient for the X term was actually a constant, so we're going to put that in. So the way you would enter a letter is we're going to do alpha. You press the alpha button, and then you press the green. The letter is above it, so this would be K. And now press enter. And then we're going to put in a -3 for the B term. We're going to put in 4 for the C term. Then we're going to press 2 again for the second line. And the A term is 4. The coefficient for the Y term is a -5. And then the constant was 7. And when we press enter, bam, it will solve it for us. It says, in this example, K would be 2.4, or they wanted it as a fraction, so you can convert this to a fraction by doing alpha, Y equals, and then option 4, and press enter, and it tells you that the value for K would be 12/5. So let's get this ready for the next time through. All right, bam. Okay, so let's go over back to the actual exam, and our answer for this one would be 12/5 or 2.4. That's what K would have to be. All right, that's the change. You can now enter different letters besides X. Let's keep going. The next question is this one, number 33. It says here, in the XY plane, the equations X plus 2Y equals 10 and 3X plus 6Y equals C represent the same line for some constant C. What is the value of C? So basically, if they're the same line, that means that they have an infinite number of solutions. That's what you should get from this. So we got to find the value of C that will make these two lines equivalent to each other or equal to each other. So we're going back to the calculator. We're going to press option 5. This time we're going to choose option 3 for infinite. Press 3. And the equations were also in standard form, so we choose 2. The coefficient for the X term was 1. The coefficient for the Y term is 2. The constant was 10, so we would put in 10. And then we would choose standard again, because the second equation was also in standard form. The coefficient for the X term is 3. The coefficient for the Y term was 6. Now, the constant was a letter, so we're going to put that in, alpha C. And there we go. Press enter, and it tells us that C has to be 30. That's our answer. So when we go back over here, it tells us this is a grid-in question. We would go C equals 30. Bam. We're done. Okay? So now, let's keep going. Got a couple more questions. Now this one looks a little messy, but it's still one of the same kind of questions. It's saying in the equation above, A is a constant. If no value of X satisfies the equation, what is the value of A? So they're saying that this equation has no value of X that will satisfy it, that will make this equation a true equation. So basically what they're saying is this has no solution. So this one has no solution, all right? So what we're going to do is we are going to go to the calculator and enter it. Now, before I do that, I'm going to simplify this so that we can enter it over there easily. So on the left-hand side of the equation, we're going to have 2ax minus 15. So the slope is 2a. The y-intercept is going to be a -15. And then on the right-hand side, we've got 3x here, 5x, so it's going to be 8x. And then we got 3 times 5, and then we got 5 times a -1. So that is going to be 15 minus 5, which is a plus 10. So now that we've simplified that, we'll just go enter it. We're going to go press enter. Now in this case, we're going to go 5, but and we want, this is no solutions. So we would choose 2. Now this time the format is slope-intercept format. So what we're going to do, press enter. The slope was actually 2 times the constant a. So that's what we're going to put in. We press enter. And then the y-intercept was a -15, so we would enter that. And then we have on the right-hand side, it was in slope-intercept form. So that one, we simplified it to 8 for the slope, and then the y-intercept was a +10. And when we press enter, it tells us that a must be 4. So if we go back to the actual question, a must be 4. All right. Now, I'm not sure if I took this from the calculator section or non-calculator section, to be honest. I was just looking for questions that I could test on. I could test the program on. So I'm not sure if this actually occurred in the calculator section or the non-calculator section, but I just wanted to show you how you could use the calculator if it does show up in the non-calculators or the calculator section. All right, so that. Now, I've got 2 more questions, and what's special about these is that it has 2 constants that are unknown that we've got to figure out, because we want to know what's the ratio of A to B. So other than that, it's pretty much the same as the ones we've done before, but this one has 2. So here's what I'm going to do, and this is what you should do. Always plug in for one of the unknowns and then solve for the other one. So I'm going to say B is equal to 1, and then we're going to solve for A. So here's what we're going to have. Our equation is going to be AX minus, we're going to put a 1 in there, so it's going to be 1y equals 9. That becomes our second equation, okay? So now let's go over to the calculator, and we're going to enter it, and that's going to, okay, press enter. We're going to go option 5, and this one has no solutions. Actually, I didn't read it. Let's go back so I can read that. Sorry. Let's go back, and I'm going to read it because I didn't read it. I realize that. It says the system of equations above has no solutions. And if A and B are constants, what is the value of A divided by B? Or what's the ratio of A to B? So we want to find the ratio of A to B that makes this system have no solutions. All right, so let's go back and finish what we were doing with the calculator. So now we choose option 2. It was in standard form. So the coefficient was 3 divided by 4, 3/4. The B was a -1 divided by 2, or -1/2. The constant was 12. And then we're going to choose 2. And this one, we're going to put in the A, alpha A. Oops, clear. Alpha A. And then we're going to put in 1, but there was already a minus there, so it's going to be a -1. We put in a 1 for B, but there was already a minus sign there, so it's going to be a -1 that we have to enter here. So it's going to be a -1. And then the C term was 9. So when we press enter, it tells us that A is 1.5. So if we go back to the test, we'll see that if A is 1.5, then that means 1.5 divided by 1 is still 1.5. That's why I actually chose 1 for B. It simplifies this problem. Now, so that's how you should handle it. But technically, you can put any number that you want to in for B except for 0. That's the only number that you can't use. But when you solve for A, you're going to have to calculate the ratio in order to get the answer, but it should be 1.5. Doesn't matter what number you put in for B, right? You can put 10 in for B, and if 10 is in for B, then A would be 15. If B is 10, then A is going to be 15. When you divide that, you get 1.5, okay? All right, now, last question. Now, here is another question that also has 2 unknown constants. Now, in this one, they're not asking for a ratio. They actually want you to solve for B. Let me read it. It says in the equation above, A and B are constants. If the equation has infinitely many solutions, for what value of x is the value, or for infinite many solutions for x, what is the value of b? Okay, so these two, this equation has an infinite number of solutions, but we got to figure out what a and b need to be. So here's what I'm going to do. I'm just going to simplify this. Ax plus ab equals 4x plus 10. Now, what I'm going to do is the same thing I did in the last question. I'm going to solve for b, or I'm going to plug in for b. I'm going to say b is 1, and then I'm going to solve for a. So let me do this real quick. I'm going to take the b, move it over here, and then come here. And so here's what we're going to have. It's going to be ax plus a times 1. We can do 1a equals 4x plus 10. So this is what we're going to enter. And then once we solve for a, we're going to use that value of a and plug it back in, and then we're going to solve for b. Let me show you how I would do this. Basically, up here, I say you're going to run this twice. And let me show you what I mean. So if we go back to the calculator, we press enter, and it's a system of equations. This has an infinite number of solutions, so we choose option 3. It was in slope-intercept form, so we're going to press 1. The slope for the left-hand side was a constant, a, and then the y-intercept was alpha a times 1, because we put in a 1 for b. So I'm going to put a 1 here. I don't have to, but I just want you to understand this is still going to be a times 1. So I just want you to see what we're doing. Now, press enter, and now I am going to go to the right-hand side. That was also in slope-intercept form, and the slope was 4, and the y-intercept was 10, and when I press this, it tells me that the constant a is going to be 4. So now that I know what the constant is, I can go back. Let me go back over here and show you exactly what I'm doing. This is taking a little bit more time, but I want to make sure it's clear. So now what I'm going to do is I am going to take, let's take this color, and I'm going to plug it in for a, because I know that a is 4. So this is going to be 4x plus 4. And now I'm going to put the b back in, and I'm going to solve for that. And that's what we have. Actually, you could just look at this. 4b equals 10, so b is going to be 2.5 or 10 over 4. But I want to show you how you would do it with the calculator. All right, so let's go back here. There we go here. And so now we're going to press enter. We're going to press 5 again. We're going to do infinite solutions, slope-intercept form. And the slope is 4 because we just calculated. It's going to be 4 times. This is what we're trying to solve, the b now. And then the second half of the equation is 4, as it was before. And the y-intercept is 10. When you press that, it tells you that b is 2.5. That is what we were trying to find. That is what we expected. We're all good. You would grid in 2.5, or you could put in 10 over 4, or you could put 5 over 2. Any of those would work, and you're done. So we ran it twice because there were 2 unknown constants. If there's only one unknown, you just run it once and it'll calculate it for you. It doesn't matter what the letter is, a variable, the constant is. You can put A, B, C, D, all the way to Z. Okay, now I'm done. I just wanted to recap. I've changed Alinear so that it will calculate, find the one solution. If there is an unknown, it can find the unknown for no solutions or the unknown for infinite solutions. I think that's valuable for a lot of students. It can handle any letter, any constant, A, B, C, D, E, F, G. You just have to use your alpha key. And if there are 2 unknowns, what you should do is plug in for one and solve for the other. And if necessary, you have to run it twice. Now, I haven't seen a lot with 2 unknowns, but as you just saw, there are some questions that have that. So you should be prepared to handle that. Now, if you want a copy or an updated version of the Alinear program, this is what I need. I need your email address. Now, this is what's new and important. When you respond tell me what kind of calculator you have, because I have a different version for the TI-84 Plus versus the TI-84 Plus CE, okay? So you gotta tell me what kind of calculator you have, because that'll tell me what I need to send to you. Also, if you would, please subscribe to my channel, and I would love it if you would like the video, because the more likes, the more eyeballs, the more students that I can help, and that's my goal. I'm trying to help as many students do as well as they can on the SAT and the ACT and the PSAT. So the more likes that you guys put on my videos, the more eyeballs I get, the more students I can help. All right, so make sure like the video, subscribe, send me your email, tell me what kind of calculator you have. I will talk to you guys again, because I've got a couple more programs that I want to put out. But please, everyone stay safe, and I'll see you later.